Dear students, welcome you all for the today's session, graph and shortest path algorithm, mainly the Dijkstra shortest path algorithm. In this session, we're going to discuss about what is a graph and the terminologies associated with that graph, like what is edge, what is vertices, and how that Dijkstra algorithm going to find out the shortest path from one node to another one node. A graph is an abstract data structure that is used to implement all the mathematical concepts of graph. It is basically a collection of vertices and edges that connect these vertices. A definition for the graph. A graph can be defined as an ordered set of G, V, comma E, where V of G represents the set of vertices and E of G represents the set of edges which were used to connect these vertices. For example, if you consider this graph has A, B, C, D, E vertices. So this graph has five vertices and six edges. The edges are A to B is one edge, B to C is another one edge, C to E, E to D, and D to B, and D to A, etc. And this is an undirected graph. Why this is an undirected graph? Now, here we are not having any arrow. If arrow specified, na, then that is called the directed graph. So graph broadly classified into two types, directed graph and undirected graph. Okay. So the earlier, which one we saw, this is called the undirected graph. And here, this is an example for directed graph. So edges form an unordered pair. Edges represent the specific path from some vertex A to another vertex B. Node A is called the initial node. If the arrow is specified like this, now, so this is the initial node and this is the terminal node. So directed graph specifies the source node and the end node. Okay. So this is an example for the directed graph. Path can be defined as a sequence of nodes that are followed in order to reach from one source node to the terminal node to the end node. Source node, if you take a U and end node as a V, so to reach the source to the destination node, what are all the nodes you going to travel? That is specified with the use of the path. And another one is called the closed path. A path can be called as a closed path if the initial node is same as the terminal node. If you reach the same source node as a destination node, na, then that path is called the closed path. Then another one is simple path. If all the nodes of the graph are distinct, with an exception v0 equal to vn, such a path is called the simple path. Another one is connected graph. Connected graph is the one in which some path exists between every two vertices u comma v in the v. There are no isolated nodes in the connected graph. A graph is to be a complete graph. Complete graph contain n into n minus 1 divided by 2 edges, where n is the number of nodes in the graph. Weighted graph. Each edge is assigned with some data such as length or weight. So the weight of an edge can be given as weight of E, which must be a positive value indicating the cost of traversing of the edge. Dijkstra algorithm. Now I'm going to explain about Dijkstra algorithm, how it will be used to find out the shortest path from the source to the destination node. So Dijkstra algorithm is a popular algorithm for finding shortest path. Dijkstra algorithm finds the shortest path to the graph vertices in the order of their distance from a given source. First, it finds the shortest path from source vertex to the neighboring vertex, and then to the second neighboring vertex, and so on. For example, let us consider the graph given below. Here, source vertex is E and end vertex or destination vertex is E. So, we going to calculate the shortest path. Either you're going to travel through A, B, C to E, or A, B, G to E. Which one is the shortest? By using the Dijkstra algorithm, we're going to calculate that one. Okay. And how the Dijkstra will calculate the shortest path algorithm? Na? First, it calculates the neighboring vertex distance. Once it reached that one, and then again it calculates the neighboring source vertex. So, by subsequently doing this, it will reach to the destination node. Okay. So, this is the initial configuration. So, you have to draw this table and you have to list it out the number of vertices in the given graph. So A, B, C, D, E. During the initial configurations, you know only the source vertex and its distance is 0 and the path is 0. For all other vertex, we don't know the distance. Okay. So 0, 0 and infinity and PV is 0, 0. So this is the standard procedure to do the Dijkstra algorithm. Initially, you know only source vertex A and you don't know about the distance and its path. So 0, 0, 0. For all others, infinity and 0, you have to do like this. Okay. So vertex A is taken as a source vertex and it is marked as visited. Then the distance of its adjacent vertex is updated by using the formula. For the source vertex A, the distance of the adjacent vertex is only B and D. So we need to calculate the dB dot distance is equal to using the formula dA dot distance plus cost of that edge A to B. Cost of the edge is 3 and it is given in the diagram itself. So dA dot distance is equal to 0 from this table. dA dot distance is equal to 0 plus cost of that edge A to B equal to 3. Excuse me, which is less than infinity. Hence, its distance has been updated. Okay, so now the distance is 3, which is less than this infinity. So we can update that one. In the same way, TD of the distance is equal to TA of distance plus CA to A to D, that edge value is again calculated. So the distance is 7 and which is less than the infinity. So it has to be updated. So after first distance calculations, so the distance of the vertex B and vertex D is marked like this. Okay. And then after completed this table, then vertex B is marked as visited. Then why we have selected vertex B as marked as visited? Na? Compared to vertex B and vertex D, which one is having shortest distance? Na? B is the 3 only, right? So we're going to take as a 3 as a known vector. Okay. So known vertex. So vertex B is marked as visited and the distance of its adjacent vertex is updated. So which one is the adjacent vertex of this vertex B? Na? Vertex C and D. So we need to update the vertex C and D by using the formula like this. DC dot distance is equal to DB dot distance plus CBC. The cost of edge B to C is 4. Okay. DB is 3. From the table, DB is the 3. And the cost of BC is equal to 4. Cost of BC, how it is 4? It is given in the graph itself. Okay. So 3 plus 4 equal to 7. Again, which is less than infinity. Hence, we need to update this one in the next table. And again, the same way, TD of distance. TD of distance is equal to dB dot distance plus CBD. In the same way, dB of distance from the 3 plus CBD edge value is cost value is 2, which is 5. Now it is less than this distance 7. So it has been updated. So the next diagram will be like this. Okay. So B is visited and the neighboring node distance calculated like this. And among this one, the vertex C now has been marked as a visited. Vertex C now has been marked as a visited and the distance of its adjacent vertex is calculated by using the same formula. DE dot distance is equal to DC dot distance plus cost of the edge C to E. So 7 plus 6 is equal to 12, which is less than infinity. So in the next table column, we're going to update this distance value. DD dot distance is equal to DC dot distance plus DC dot distance plus C, cost of that edge C to D. So now the value is 12, but which is greater than this one. So we should not update this one. If the value is less than the previous distance now, then only we can update that distance, or otherwise we should not update that one. Okay. So after this one, the tablet column will be like this. Okay, next, the vertex D has been marked as visited, and the distance of its adjacent vertex is calculated as follows. Now, that edge vertex, after selecting D as a known vertex, the vertex E distance can be calculated as a 9, which is smaller than 12. So, this is updated in the next tablet column. Okay, so this is updated in the next tablet column. Finally, you have reached the vertex E and you have visited all the node in the given graph. So the last distance, so the shortest path to reach from source A to the destination E vertex is A to B, B to D, and D to E, 9. So this is the procedure of Dijkstra algorithm to find shortest path from source vertex to the destination vertex. So overall summary, each and every step we need to do the tablet column. You have to list out the number of vertexes and this one number of vertexes and known value, whether you have visited the vertex or not, and then the distance and then the path value. Okay, then each and every adjacent vertex you have to calculate it. Once you reach A, adjacent vertex distance you have calculated. Once you reach the B, adjacent vertex node is calculated, distance is calculated. Okay, so which one is shorter, we going to evaluate. So this is the procedure of Dijkstra algorithm to find shortest path from the source vertex to the destination vertex. Thank you so much. Thank you for the watching. All the best.